review of the Edgenuity lesson, graphing exponential functions. So for this video, I'm going to show you the way that I teach graphing exponential growth and exponential decay in the classroom, and maybe that'll help you with some of the quiz problems. So an exponential function is exponential because the variable is up in the exponent. To be exponential growth, the base value, so the big number on the bottom, it has to be bigger than 1. So anything bigger than 1 will make it growth. Anything between 0 and 1 makes it decay. So like 1/2 to the power of x, 0.75 to the power of x, 1/3 to the power of x. Notice it's between 0 and 1 and not just plain less than 1. You can't have a negative there. So looking at how the shifts work and whatnot, when you go to graph, what we're going to do is we're going to make a table. And the part that we're going to put in the table is anything that's being multiplied in the front, the base, and just the x. Anything that's being added or subtracted, we are not going to put in the table. We're going to deal with those separately as shifts. So this number out here in the front, a, what it does is if it's negative, it will cause a reflection. So instead of being above the x-axis, it then is below the x-axis. H, so if there's a plus or a minus up in the exponent, that's in charge of moving your graph left or right. If it's a positive, so x plus 3, you would go to the left. If it's something like x minus 2, you would go to the right. So it looks kind of like the opposite. If there's a number being added or subtracted off to the side, not in the exponent, but off to the side, that's in charge of moving your graph up or down. If it's positive, you go up. If it's negative, you go down. When you graph these, there is an asymptote at the x-axis, so you can't go across the x-axis. Now, with that being said, if you ever shift up or down, the asymptote will shift up or down with you. So looking at this first example, it says graph y equals 2 to the power of x minus 1 minus 4. And then we're going to state the domain and the range afterwards. So this is the part that we're going to put in the table, just the 2 to the power of x. We have nothing being multiplied in the front, so that makes it easy. So I'm just going to go ahead and plug in 0, 1, and 2. So anything to the power of 0 is 1, 2 to the first power is 2, and 2 squared is 4. So those are, I have 3 ordered pairs there. Okay, so this is what kind of like our template, our basic graph. And from there, we're going to take these points and we're going to shift them with these shifts that are listed right here. So 0, 1, 1, 2, and 2, 4. Okay, so I'm going to dash this in because it's our basic graph, not the final answer. Remember I said we're not going to go across the x-axis yet because we're not factoring in the shifts yet. So we got to level out and not go across that x-axis. So up here in the exponent, we have x minus 1. This is what we do normally in school as well. We write it's called the book. So it like describes the graph or the shifts. So remember, if it's a minus value up here, then we're going to shift to the right. So it's x minus 1, so that means I'm going to go to the right 1. And then this one here is minus 4. So remember the number off to the side is in charge of up or down. So this means we're going to go down 4 since it's negative. So all 3 of my points here, I'm going to go right 1, down 1, 2, 3, 4. Right 1, down 1, 2, 3, 4. And right 1, down 1, 2, 3, 4. Now, before I connect those, remember I said if you move up or down, that asymptote that was here is also going to shift down. So since we went down 4, our new asymptote is right here. So we're going to dash that in so we know don't go across this line. So your domain always for these exponential graphs is all real numbers. You can plug in anything. But for range, that changes based on where your asymptote is. So if you notice, we're cutting out here at -4. So that means our range has to be above -4. It can't be below it because it cuts off there. And it never actually will be -4 because that's what an asymptote is. You can't touch it at all. So this one would be y is greater than -4 because it goes from -4 up. Okay, this one is going to be exponential decay because our base value here, 1/2, is between 0 and 1. So what we put in the table, if there's a number being multiplied out front, that goes in the table, your base, and just the x. So let's just do 0, 1, and 2 again. I'm going to leave a little more space on this one. So 3 times 1/2 to the power of 0. Remember, anything to the power of 0 is just 1. 0 is only on the half, so you still got to multiply it by 3. So 3 times 1 is 3. 1/2 to the power of 1 is 1/2. So 3 times 1/2 is 3/2. Which is about it is 1.5 if you want to use that decimal value. And 3 times 1/4 is 3/4, which is 0.75. Okay, so now let's graph. Remember, we're doing the basic graph first, so we're not going to worry about the shifts. So I'm going to plot those 3 points on there, 0, 3, 1 was 1.5, and 2 was 0.75. So again, this one is decay. So as your x values get larger, your y values go down. Still can't go across the x-axis though. Okay, so now let's look at our shifts. We are going to go, so up here in the exponent it says x plus 2. It's in charge of doing left and right, and you kind of do the opposite. So this is plus 2, so I'm going to go to the left 2 on all the points. And over here is in charge of up and down. We have a positive 1, so we're going to go up 1. So all 3 of these points are going to go left 2, up 1. Left 2, up 1. Left 2, up 1. All right, and again, that's going to change our asymptote. This asymptote was the x-axis, but since we shifted our graph up 1, I need to move that asymptote up 1. I can make it a little longer. There we go. Okay, so for this one, again, the domain is always all real numbers. And the range for this one, so it's basically from the asymptote up. So our asymptote, we had to shift it up to 1. So every value of y is going to be above 1. That's our range.